Hello everyone. This will be our last lab activity and we will focus on converging lens. So in this activity, we will have the fundamental lens equation given the following: 1 over d sub naught plus 1 over di, which is equal to 1 over f, wherein d sub o or d sub naught is the object distance from the lens. So therefore, if you have here your object, the object is actually beside your light source. And DO is the object distance from the lens. This is your D sub naught, or this is your DO. And DI, on the other hand, is the image distance from the lens, wherein you will see the image on the screen here. So this will be your, from this point to this point, this is your DI. And then F is the focal length of the lens, which you will measure later on. And at the same time, we will be using the magnification equation, which is equal to M is equal to negative DI over D sub naught. Okay? Now, initially, ideally, the light source should be 1 meter away from the screen. However, if you will look at our track later on, you would notice that we might not be able to get that 100 centimeters distance from your viewing screen up to your light source. By the way, this is your viewing screen. This is where you will see the image. This is your holder that holds the lens. And this is the object, which is an arrow, and this is your light source. So we will still use the blue box for this experiment. And if we're going to zoom in, we will be using a convex lens that has a 75 mm focal length, or 7.5 cm. This is your object, which is an arrow, which you can find in the blue box. And you have to connect it to the holder to stand. This is your light source, which is the light source that we normally use. And this is the viewing screen. Okay, so the setup is you'll have the lens in between your viewing screen and the light source and the object. And then the first thing that we have to do is, of course, the setup. After that, there will be no light source first. So we will do this all together. There will be no light source first. You will turn off the light source, okay, or your light. And then the only light source that we will have is the door here. So you have to align your table or your setup, this setup in such a way that wala muna to, okay, wala muna tong this part of the activity. Ito muna, and you have to make sure that this lens is facing the door and this viewing screen is on the other side. Okay? And so, what's gonna happen is that we have to find this image of the door, okay? Wherein, how to find this? You have to slide this lens, okay? You have to find a specific position of the lens with respect to the viewing screen in such a way that you will see a clear image of your door. And you would notice that there is a rectangular sticker here, and then when you see the image, okay, this is the rectangular sticker. Therefore, the image form was inverted. All right, so you have to find that distance of the lens from the viewing screen in such a way it will produce a clear image of this door. That's the first thing that we have to do. And that is where that is what you're going to write here, the image distance, or the distance of the image from the lens. And the focal length is the focal length is written on the lens given, which is in this case, we have the 75 mm, or in terms of cm, that's 7.5, and get the percent difference. So that's the first part. We will do it together so that we will only open the window door once. Then once we're done with the part 1, okay, object very far from lens, then we will move on to part 2. Okay, which is closer than infinity. Then we will now close this window door, okay, and then you can turn on na your light source, and then you will have this set up na. And then in this case, if, for example, hindi kaya yung 100 cm, the distance of the viewing screen to the object, then just change it. For example, kung ang kaya lang ay 60 cm, okay lang. This is 60 cm or 70 cm, it's okay. Then this becomes 50 and this becomes 40. Kahit tatlong setup lang, okay na. Or tatlong distances. Okay? And you have to get the following. Distance of the object from the lens, distance of the image from the lens, then do the math here. At the same time, you have to measure the height of the image formed and the height of the object. In this case, you have to measure this object and then get the magnification using these equations. Now, in terms of measuring the images or the height of the image, it's better if you will just get a specific part of the object. For example, ito lang. This is what you're going to measure lang. Okay? When you measure the object, therefore, you will only measure this part of the object. And so, when you get the image, you will only measure this part of the image. For example, here. Anong measurement nito? Or pwede namang what do you call this? Itong horizontal line lang na to. Okay? Though kasi, you will see two images. Okay? You have to see two images. Kaya meron kayo ditong dalawang row. Okay? Yung first image that is closest to the object and the second row that's closest naman to the viewing screen. So, pwede magkabaliktad. It's okay. Okay? But the thing is that you have to ensure that you can measure also the smaller image kasi it's quite very small. So, you have to make a way so that you can measure this small image, you can also measure the big image. Kasi for example, ito, pag small image, kasyang-kasya yung buong object. Pero pag the other image naman, hindi kasya yung buong object. So you have to make a way so that you can measure at least some parts of that image. Pwedeng itong part lang na to, though pag dito kasi hindi mo ma-measure eh. Or pwedeng itong end-to-end ng circular path para ito siya. Okay? And yeah, kayong bahala. Alright? So ayan. So what we have to do is to get a clear image of these objects or of these images. Okay, it's like this. Wait, I will just go to the other screen so that you could see. Wait lang. What happens para makita nyo what's really happening kapag minumove yung screen. I'll just share my other screen. So we have here. So I actually took a short video para you can see how does it change here. Okay, so this is a short clip. So look at this image and look how it changes as I move this lens from here to here or left or right. Okay? So you've seen that nagbabago yung clarity ng image. So what we have to do is to get is the clear image of that. Okay? The next is we have to move on, okay? Once you gather the data here, okay, here, you have to plot the graph of 1 over di versus 1 over d naught and draw the best fit line. Make sure you will use Excel and find the y-intercept and then get the experimental 1 over y for the focal length and also get again the focal length as indicated on the label of the lens and get the percent difference. And after that, answer the following questions. Okay? So, yeah. So, please be on time on Monday and see you there. Bye, everyone.